We are starting 5.3a today. So trig from any angle. So we are going to find out the trig ratio for any angle, not just specific angles. So we are going to draw triangles in the coordinate grid using the coordinate pair. So if I think about this, my quadrants, x, y, -8, -15. So I'm going to find that here. So it's in quadrant 3. So this is -8, and this is -15. So we are going to make a right triangle here. And so this is going to be called theta prime. Theta prime is going to be an angle that is kind of compared to theta. And when we do trig ratios, we're going to have the same ratios. The angle is not the same, but the trig ratios are the same. So what we are going to do is make sure you draw the triangle. Hold on, cancel. Draw a triangle. Draw X. Draw a triangle with X axis. Okay, and then this is going to make a right angle. So this is X, this is Y. So whenever we look at theta prime, we have that X is going to be the adjacent and Y is going to be the opposite. And then we have to use Pythagorean theorem to find the hypotenuse. So let's go ahead and do that. So we have -8 squared plus -15 squared equals c squared. You do the math, 64 plus 225, take the square root, and c ends up being 17. So our hypotenuse is always going to be positive, but x and y can be positive or negative. And it depends on what quadrant they're in. Okay, so now we're going to find our 6 trig ratios. So sine theta equals -15/17. Cosine theta equals -8/17. Tan theta equals -15/-8, which ends up being +15/8. Okay, then we do our reciprocals. And secant and cotan. Okay. All right, let's look at the next one. -1, 1. So our x value is -1, our y value is 1. So let's say that this is -1 right here. And then we're going to go up 1. So we're going to draw the line of our leg. So like -1 and +1. Then make your triangle. So where the origin is, where that angle is near the origin, that's our theta prime. Okay, we're going to do the same thing. We are going to find out what our hypotenuse is. So -1 squared plus 1 squared equals c squared. So that ends up being c is square root of 2. So this is adjacent, this is opposite, this is hypotenuse. So sine theta, 1 over square root of 2. Don't forget that we've got to rationalize square roots. So we're going to multiply top and bottom by square root of 2, which gives us square root of 2 over 2. Cosine theta, -1 over square root of 2, which ends up being the same thing, negative square root of 2 over 2, but negative. Then tan theta 1 over -1, which just is -1. Okay, cosecant. I'm going to go back to my original. I'm going to go back to this guy right here before I rationalized, because that just gives us square root of 2 over 1, which is just square root of 2. Secant, same thing, negative square root of 2. And then cotan is going to be just -1, because if you do the reciprocal, you get the same thing. All right, we're going to do 3 and 4 in class. Let's go to the next one. Find the values of the 6 trig ratios of angle theta. All right, so they gave us function value and they gave us the constraint. So if we make our xy axis, so it says quadrant 3. Okay, so we know we're here. It says that cosine is -4 over 5. So let's think as to what cosine is. So cosine is, remember, sine is y, cosine's x. So cosine is really x over 1 or x over r. And that's actually on your formula chart. So we know that r is always positive. That's what we learned in examples 1 and 2. So that means that r4 has to be negative. So our x value is -4. So I'm going to go over to -4. Let's just say that's -4. And it has to be in quadrant 3. So it's going to look like this. Something like that anyway. And so our radius is 5. Because that's what it tells us right here. So x is -4. Radius is 5. So let's use Pythagorean theorem to find the missing. Let's change colors real quick. -4 squared plus b squared equals 5 squared. Oh, this should be theta prime, by the way. So b equals 25 minus 16 is 9. Square root of 9 is 3. This is a 3, 4, 5. And this has to be negative because it is going down. And remember, in quadrant 3, we have negative, negative as our values for x and y. So now we do all of our trig ratios. So sine, theta. Okay, so this is opposite. This is adjacent. And this is hypotenuse. So opposite over hypotenuse. Cosine, we already know. It's -4 over 5. Tan is -3 over -4, which is positive 3/4. Okay, let's do cosecant. That is just a reciprocal. And the negative, it doesn't matter where it goes, top or bottom. So I always just put it with the top. Then cotan. All right. We will do 6 together in class. Okay, let's look at the next one. The terminal side of theta lies on a given line in specific or specified quadrant. Find the values of the 6 trig functions by finding a point on the line. All right, so we first need a graph. So this would be like plus 0. So we start at our y-intercept at 0. Then we go up 1 over 3. So this is the line. But whenever we do our angle, remember the x-axis is one of the legs, and then going up to the point makes a right angle. This is 3. This is 1. So then this is theta prime. So we actually don't care about anything else. We only care about the angle of the right triangle. So using Pythagorean theorem, we would find our missing side. So 1 squared plus 3 squared equals c squared. So it'd be 10, so c is square root of 10. So now we do sine theta. So this is opposite, adjacent, and hypotenuse. 1 over square root of 10. Can't leave it like that, so we multiply both sides by square root of 10, or top and bottom square root of 10, which gives us square root of 10 over 10. Cosine theta is going to be 3 over square root of 10, which gives us 3 square roots of 10 over 10. Tan 1 over 3. And everything's positive on this one too, because we're in quadrant 1. All right, cosecant, flip them. So I go back to my original, so square root of 10 over 1. Secant, square root of 10 over 3. And then cotan, 3 over 1, or just 3. Okay, we'll do this one in class. All right, we will do the rest of this in class as well. All right.